Hey friends! Tonight we're venturing into how to destroy the universe. Imagine drifting through endless galaxies, tracing the quiet hum of stars, and then pausing to wonder, what if everything, the cosmos, time, light, and matter slowly unraveled? Tonight we'll explore the gentle, mind-bending science behind cosmic endings, the ways the universe might fade, and the subtle rhythms that keep it moving even towards silence. This video is here to help you relax, float through the vastness of imagination, and maybe spark a flicker of curiosity that keeps your thoughts awake just long enough, all while easing you toward a calm, reflective state. Think of it as a bedtime journey through the ultimate cosmic story. If you enjoy these cosmic adventures, a like or subscribe helps our quiet corner of wonder grow. And leave a comment sharing where you're watching from. Perhaps a midnight balcony in Buenos Aires, a sleepy attic in Kyoto, or even your kitchen at 3 a.m. while the fridge hums along. So put on your headphones, close your eyes. It's made for relaxation and learning. The universe is vast, yet it is fragile. From the moment it was born in a flash of fire and light, everything has been balanced on rules so delicate that even the smallest change would have made a different world. When you look up at the night sky, every star shining above you is a promise kept by these rules. Gravity pulls quietly, light travels in patient lines, time moves forward like a river that never stops. Together, these laws create the fabric of everything you know. Imagine the universe as a great woven cloth, stretched wide and endless. Each thread is a law of nature, a rule that holds the fabric together. If even one thread were to break, the weave would begin to loosen. The stars might not burn, the planets might not spin, atoms might not hold their shape. Reality itself might fade. It feels eternal, yet it is delicate, like frost on a window or ripples across still water. For billions of years the fabric has held. Galaxies have formed, stars have lived and died, and planets have carried oceans and life. But the same fabric that creates all beauty also contains within it the seeds of its own end. The rules that make everything possible also whisper of endings. They are not cruel, they are not kind, they simply are. The universe may last for an unimaginable time, stretching farther than your mind can reach, but every possibility of destruction rests hidden in its laws. Some endings are quick, sudden and sharply, a glass shattering in silence. Others are slow, patient, stretching across eons, like the last embers of a fire going dark. To understand how the universe might end is to understand how fragile it has always been. Close your eyes and picture the cosmos as a bubble floating in darkness. From afar it looks solid and bright, filled with stars like sparks of firelight. But up close you see the thinness of its skin. The bubble is stretched tight, held together by forces that cannot be seen. Yet they are the only reason it exists at all. This bubble could drift forever, glowing against the void. Or it could burst, vanishing without warning. The idea that the universe could be destroyed feels heavy, but in truth it is simply another part of its story. Nothing in nature lasts forever. Mountains crumble, rivers dry, stars die. The universe, though vast beyond measure, may be no different. To think of its end is not to invite fear, but to invite wonder. How can something so enormous be so delicate? How can everything, galaxies, black holes, light, life, rest on such fragile threads? The first thing to understand about the universe is balance. Every law you know is a kind of quiet agreement. Gravity agrees to pull, light agrees to move at one speed and no faster. Electrons agree to orbit, never falling into the hearts of atoms. These rules do not speak, but they act like a soft rhythm, a hidden music that everything follows. If the notes of that music were even slightly different, the song would not play. If gravity were a little stronger, stars would collapse before they had the chance to shine. If gravity were weaker, stars might never ignite at all, leaving a universe of dark, lonely clouds. If the charge of the electron were only a little different, atoms would fail to bond. The chemistry of life would never unfold. You would not be here to wonder about it. This delicate balance is what scientists sometimes call the fine-tuning of the universe. It does not mean the universe was made with intention, only that it rests on exact numbers. The tiniest changes could unmake it. The whole of reality feels enormous when you stand beneath the stars, but in truth it is balanced on the edge of a knife. Think of a tightrope walker moving across a wire. Step by step, the walker leans and sways, but the rope holds. The universe is like that rope stretched across the dark. For now, it holds steady. Galaxies spin like pinwheels. Stars burn in their quiet billions. Planets drift in their orbits. But a rope can fray, a rope can snap. You may ask, how could such a vast thing be so fragile? But even vastness does not mean safety. The ocean is enormous, yet a storm can churn it wild. A mountain is ancient, yet wind and rain wear it down to dust. The universe is the greatest stage, yet the laws that hold it together are as soft and delicate as spider silk. The story of destruction does not begin with violence, it begins with change. The laws themselves may not stay forever as they are. They could bend, they could shift, and if they do, the fragile weave might begin to tear. There would be no warning, no sound, no sign, just a slow unravelling of the music, and the fabric would begin to fail. But even if the laws remain steady, the universe still holds endings inside itself. The stars, so steady and bright, carry fire that cannot burn forever. The galaxies, so grand and beautiful, are moving away from one another, pulled by something invisible and strong. Even the smallest particles, the very bricks of matter, may not last. Over time, everything that feels certain may fade. Look again at the night sky in your mind. Imagine those stars as candles. They are burning in a room of endless dark. They flicker, they shine. But candles do not burn forever. Their wax runs low, their light grows dim. The room, no matter how many candles you place in it, will one day grow dark. The universe is no different. It is filled with fire, but every fire will someday fade. The universe is like a clock, its gears turning with perfect order. But even the strongest clock winds down. The energy that fuels it spreads thinner with every tick. Over trillions of years, the hands may still turn, but slower, quieter, until at last they stop. This is not something you will see in a human lifetime, nor even in the lifetime of all humanity combined. It is a story written on scales so large that your mind can only imagine the edges of it. Yet the story is real, the clock is ticking. Every law, every constant, every particle is like a grain of sand pressed into glass. Together they form a window clear enough to let the universe exist. But what if the glass cracked? What if the grain slipped free? You would not only lose the window, you would lose everything the window looked upon. When scientists study the cosmos, they find whispers of these endings. They do not speak in fear, but in awe. To think that the universe, so grand and infinite in appearance, carries within it the same fragility as a single flower, is a thought both humbling and strangely comforting. Life itself is fleeting yet beautiful. So too may be the cosmos. The fragility becomes clear when you look at beginnings. In its first breath, the universe was a storm of energy and light. From that storm came matter, stars, and galaxies. But the same storm left behind instability. Just as a fire leaves behind ash, the birth of the universe left behind possibilities for decay. The very act of beginning meant there would someday be an end. Think of a drop of dew in the morning sun. It glimmers perfect and round. But as the day warms, the drop thins. It slides into nothingness, leaving no trace of the form it once held. The universe too glimmers. It shines with galaxies, stars, and life. Yet in its shine is the promise that one day, like the dew, it will vanish. It is easy to believe that destruction is violent, but most of the universe's endings are quiet. No great fire, no single sound, just stillness, just slow change. Heat spreads, light dims, motion stops. The beauty of endings is not in their violence, but in their patience. They wait beyond all lifetimes, moving gently step by step, until the fabric of reality is folded away. And so, to understand how the universe can be destroyed, you must first understand its fragility. It is not stone, it is not steel. It is a whisper of laws, a harmony of forces, a delicate cloth stretched across infinity. That is why we can speak of its end, because everything that is delicate, no matter how large, must someday fall silent. To stand inside this story is to feel very small. The universe seems endless, but your life is just a flicker compared to its age. Yet in that flicker, you can look up and notice. You can wonder. You can see the stars and know that they too are temporary. Perhaps that is what makes the universe most fragile of all. It can be seen and understood by creatures who last only a moment. Imagine holding a snowflake in your hand. Its shape is delicate, its pattern unique. The smallest touch of warmth will melt it. The universe is vast compared to a snowflake, but in truth it shares the same nature. It has shape, it has pattern. It rests on the edge of being, always close to change. Scientists speak of space-time as a fabric. This fabric bends with gravity. It curves with mass. You might imagine it as a sheet stretched tight, stars and planets pressing into it, making valleys where other things can roll. It seems steady, yet this sheet is not immune to tearing. It could ripple. It could break. One loose thread could unravel the whole. This is why destruction is not only possible, but expected. The fabric was never meant to last forever. In the farthest reaches of time, the weave will loosen. Galaxies will drift away from one another until they are too far to see. Stars will burn their last fuel, leaving behind only embers. Even those embers will cool, becoming invisible against the dark. And still time will flow. Still change will come. To think of this is not to invite despair, instead it can bring peace. For if the universe itself is fragile, then fragility is not a flaw but a truth. Everything is temporary. The stars, the galaxies, the universe itself, all are brief in the scale of eternity. And yet, in their briefness, they shine, they give warmth, they carry beauty. Picture again the night sky. Each star you see is a note in a song that has been playing for billions of years. Someday the song will end, but that does not make it less beautiful. In fact, it may make it more so. To know that the song is fleeting is to listen more closely, to feel more deeply, to marvel at every note while it still rings. The fragile fabric of reality is not something to fear. It is something to wonder at, for even as it carries the promise of endings, it also carries the miracle of beginnings. From nothing came everything. From silence came stars. From stars came life. And from life came eyes to see it all, hearts to feel it, and voices to tell its story. Heat death. The slow fade into silence. The universe does not need violence to end. It can fade quietly, almost kindly, into silence. Among the many visions of how reality might collapse, one of the calmest yet most haunting is known as the heat death. It is not an explosion, not a fire, not a sudden crash. Instead, it is a whisper that stretches across unimaginable ages, a slow dimming of everything you have ever known until nothing is left but coldness, stillness, and endless dark. When you hear the phrase heat death, you might picture fire, or burning, or some final flare of destruction. But the truth is softer. It is not death by fire, but death by exhaustion. Imagine a candle flame, bright and flickering. As it burns, the wax grows thin. The flame shrinks, fades, and then is gone. The room is left in shadow. The universe, too, carries a flame. It glows with stars, galaxies, and light. And like every flame, it can run out. At the heart of this idea is something simple. Energy spreads out. Every star shines because its fuel is packed together, dense and hot. Every planet glows in warmth because it holds energy close. But the laws of physics say energy always seeks balance. Heat flows into cold, high pressure spreads into low. Over time, everything evens out. This is the quiet rhythm of the second law of thermodynamics, and it rules the fate of all things. You can feel this law in your daily life. A hot cup of tea left on a table cools as its heat slips into the air. An ice cube melts as the warmth of the room seeps in. The difference between hot and cold fades until both share the same quiet temperature. The universe follows the same rule. Over ages beyond counting, the hot and the cold balance. The bright and the dark become the same. The stars, the galaxies, the very atoms themselves all drift towards sameness. That sameness is what scientists call maximum entropy. It is a state where nothing can change, because everything is already balanced. There are no rivers flowing downhill, no stars burning fuel, no warmth moving into cold. Change is only possible when there are differences, when something is hotter, denser, brighter. Without differences, there is only stillness. And stillness is the end of motion, the end of story, the end of time as we understand it. Picture the universe today. It is alive with contrast. Stars blaze hot while space around them is cold. Galaxies swirl with bursts of energy while the void between them is empty. Planets glow with warmth. Moons lie frozen. Comets streak in icy arcs. It is a world of differences. And those differences make everything possible. But heat death tells us that the differences will not last. Step by step, they will fade. The universe will not crash into ruin. It will simply flatten into sameness. This future is not near. Not tomorrow. Not in 1,000,000 years. Not in 1,000,000,000. Stars will still burn for unimaginable spans of time. Galaxies will still shine. Life may even bloom in places yet unseen. But over trillions upon trillions of years, the story will change. The stars will use up their fuel. The galaxies will drift so far apart that their light will never reach one another. The bright night skies of today will someday be empty, dark and silent. The first candles to go out will be the smallest stars, the red dwarfs. They live the longest glowing dimly for trillions of years, far longer than our sun. But even they will one day flicker out, leaving behind cold remnants. Larger stars will have died earlier, in supernovas, leaving black holes and white dwarfs. Slowly the stars will all vanish. What remains will not shine. The sky will no longer sparkle with light. Instead, it will be filled with quiet corpses of suns, black dwarfs, neutron stars and black holes. Galaxies will still exist, but they will no longer gleam with the glow of newborn stars. Instead, they will be cemeteries of ancient dark matter. Even then, the universe will not be finished. The remnants will collide, merge and decay. Black holes, those deep wells of gravity, will rule the far future. For a time they will be the last kings of the cosmos, swallowing stars, dust, and anything that drifts too close. Yet even kings cannot last forever. Over immense stretches of time, black holes themselves will evaporate, releasing their energy in a slow trickle called Hawking radiation. Imagine a black hole, dark and silent, sitting in the emptiness of space. Nothing escapes its grip. Not even light. And yet, across unthinkable time, even this darkness fades. The black hole shrinks little by little, until it vanishes with a final quiet sigh. When the last black hole disappears, the universe will truly be empty. And so arrives the heat death. Not with fire, not with thunder, but with stillness. Every particle drifts apart, spread thin across infinite distance. Every bit of energy is evenly shared, so evenly that nothing can happen. No stars, no light, no warmth, no story. The universe is still there, but it is silent. It is motionless. It is a room in which the candles have all burned out. To imagine this ending is to imagine time stretched so far that it loses meaning. 1,000,000 years feels vast. 1,000,000,000 feels incomprehensible. 1,000,000,000,000 is almost beyond thought. Yet the heat death plays out over numbers even larger. It is a story of patience, of waiting, of silence growing until it fills everything. There is a strange comfort in this ending. Unlike explosions or sudden collapse, death is peaceful. It does not tear or shatter. It simply waits. It lets every star shine for its full life, every galaxy spin in its glory, every black hole rule for its age. Only after the longest of times does it gather all into silence. It is not cruel, it is simply still. Perhaps this is the gentlest fate for the universe, not to vanish suddenly, but to fall asleep, to drift into a slumber so deep that no dream stirs within it, a sleep that holds no waking, a final quiet where everything rests. For you, living in this moment, the heat. Death is unimaginably far away. The stars above you will shine for ages yet. The galaxies will continue their slow dance. The universe is fragile, yes, but it is also vast in its patience. You live in a chapter filled with light, in an age still alive with story. The silence will come, but not for a time so long it feels almost eternal. And so when you look at the stars, you're not seeing a universe that is dying, but one that is alive in its brightest age. The night sky is a reminder that endings exist, but also that beauty shines before them. To know the silence is coming is not to despair, but to listen more closely to the music while it still plays. The heat. Death is not the end of wonder. It is the reminder that everything, no matter how vast, is precious because it does not last forever. The stars, the galaxies, even the universe itself, all glow brighter in your heart because you know they are fleeting. So let the thought of heat death be not a weight, but a softness, a gentle awareness that you are part of something that shines in the briefness between silence and silence, that your life, small as it may seem, shares the same stage as galaxies, that even as the far future holds stillness, the present holds light. Close your eyes. Breathe. Imagine the quiet universe of the future spread thin and silent, then open them again and see the stars that still burn, the heat. Death will come someday, but tonight the cosmos is alive, and so are you, the big crunch, a universe falling inward. The story of the universe is not only about expansion, it may also be about return. Imagine the cosmos as a great breath. First, it inhales with the Big Bang, swelling outward, filling the void with light and matter. But what if that breath is not endless? What if it must one day exhale? That long, slow exhale is what scientists once called the Big Crunch. It is the dream of a universe that ends not in silence, but in collapse. At this very moment, galaxies are rushing apart. The fabric of space itself stretches, carrying them farther and farther from one another. You can see this in the red glow of distant galaxies, their light stretched thin by motion. It is proof that the universe is still expanding, just as it has been for billions of years. Yet expansion may not last forever. If gravity is strong enough, it may call everything home again. Gravity is the quiet pull that binds all things. It gathers dust into planets, planets into stars, stars into galaxies. Even across the vastest gulfs, its hand does not let go. If the universe carries enough matter, gravity might slow the expansion, pause it, and then reverse it. Slowly, step by step, galaxies would begin to drift inward. The long journey back would begin. To imagine the big crunch is to imagine the night sky changing in ways beyond comprehension. At first, nothing would seem different. Stars would still burn, galaxies would still shine. But across ages, the distance between galaxies would shrink. The dark spaces would narrow. Slowly, the universe would begin to fold in on itself. The collapse would be slow at first, but as galaxies drew closer, the pull would grow stronger. Their paths would bend, their shapes would twist, until clusters of galaxies merged into titanic structures of light. Stars would collide, planets would shatter. Black holes would grow fatter, swallowing everything that wandered near. The sky would glow brighter than ever before. If you could stand beneath it, you would see more stars than any human has ever seen. The heavens would burn with the fire of endless collisions, a storm of brilliance before the end. It would be terrible, yet beautiful, like watching a forest aflame in the night. And then, after unimaginable ages, the collapse would quicken. Space itself would shrink. Distances would vanish. Galaxies would no longer drift but crash together in violent tides. The fabric of the cosmos would fold like a curtain being drawn. Everything would be drawn toward everything else until all was crushed into one last, dense, searing point. That point would be the mirror of the beginning. The universe would end as it began, hot, bright, and small beyond imagination. All the stars, all the galaxies, all the atoms, even space and time themselves, compressed into a single seed of fire. That is the heart of the Big Crunch, a return to the place where all stories meet their first page. And yet, within that return lies a possibility. If the cosmos could collapse into a seed once more, might it not also bloom again? From the ashes of one universe could another burst forth. This idea is called the cyclic universe, a cosmos that lives not once but again and again. Big bang, big crunch, expansion, collapse, a heartbeat written across eternity. For now, no one knows if this is truth. The evidence of today suggests the universe's expansion is not slowing but speeding up. A mysterious force called dark energy seems to be pushing galaxies apart, stronger than gravity's call. If that force wins, the Big Crunch may never come. Yet the idea still lingers soft and haunting, like a dream of return. There is a kind of poetry in the crunch. Unlike the heat death, which ends in silence, the crunch ends in fire. It is dramatic, violent, yet strangely symmetrical. What begins in an explosion ends in collapse. The breath that expands is exhaled. The circle is closed. The story folds back into itself, as if the universe were a book that never ends, each final chapter returning to its first. Close your eyes and picture it. The stars above you, brighter than ever, pulled together by gravity's hand. Galaxies merging, skies ablaze with fire, then all rushing inward, faster and faster, until every horizon narrows into one point of unbearable brilliance. It is the end of space, the end of time, and perhaps the beginning of something new. Whether the Big Crunch will happen or not, it reminds you of a truth. Endings and beginnings are often the same. The last page of one story is the first page of another. The cosmos, vast and mysterious, may follow this same rhythm. Creation, collapse, creation again. For now, the sky above you is still expanding, still scattering galaxies like sparks. But deep inside its laws lies the memory of gravity, the endless pull toward togetherness. If the day ever comes when that pull wins, the universe will fall into itself like a wave breaking back into the sea. Until then, you live in the exhale, in the outward breath. But the inward breath still waits, quiet, possible, like a heartbeat in the chest of time. The Big Rip, a universe torn apart. The universe is not only fragile because it might fade or collapse. There is another vision, stranger, sharper, and more unsettling. It is called the Big Rip. Unlike the gentle silence of heat death or the fiery return of the Big Crunch, this ending is violent, but in a quiet way. It is the picture of a cosmos torn apart, not by fire, not by gravity, but by the very fabric of space itself, stretching until nothing can hold together. To understand the Big Rip, you must first look at what is happening right now. The galaxies are moving away from each other. This has been happening since the Big Bang, but here's the strange part. They are not only drifting apart, they are speeding up. It is as if invisible hands are pushing them, making them race away faster and faster with every passing moment. This invisible push has a name, dark energy. No one can see it, no one can touch it. Yet it seems to make up nearly 70% of the universe. It fills the cosmos like an unseen ocean, and its pressure stretches space itself. For now, dark energy feels gentle. It lets galaxies separate but does not tear them apart. Yet what if it grows stronger? What if its push never stops but increases, faster and faster, until even the strongest bonds cannot hold? That is the question of the Big Rip. Imagine you are holding a rope. At first, you pull it lightly and it stretches. The fibers hold together. You pull harder. The rope begins to thin, harder still, and the strands snap one by one until the rope unravels into threads, then into dust. Dark energy may do the same to the universe. The rope is space itself. The threads are galaxies, stars, planets, atoms. If the pull grows without limit, then nothing, not even the smallest particle, can survive. The story begins slowly. Galaxies drift apart until the sky grows emptier. Stars no longer gather in clusters. They shine alone in widening dark. From Earth, if you could live long enough, the night sky would grow lonely. The Milky Way's neighbours would fade, their light stretched away until it could no longer reach your eyes. But the rip does not stop there. As dark energy grows stronger, it does not only push galaxies apart, it begins to pull galaxies themselves to pieces. Stars are torn from their homes, flung into endless dark. The great spiral arms of galaxies unravel like ribbons in the wind. Each star becomes a lonely traveller, racing into nothing. Then comes the turn of solar systems. Planets that once circled stars with steady grace are pulled loose. Their orbits fail. They drift, lost, away from the suns that warmed them. Even the planets themselves may be stretched, their shapes twisted as the bonds that hold them begin to fail. The rip deepens. Now it reaches atoms. The bonds that tie protons and electrons together begin to weaken. The particles that form your body, the air, the oceans, the mountains, cannot resist the tearing. Molecules snap. Atoms dissolve. Even the heart of matter, the protons and neutrons themselves, fall apart under the strain. In the final moment, nothing remains whole. Not stars, not planets, not atoms, not even the empty space between them. The universe itself is ripped into fragments so small they cannot exist. The fabric is not merely frayed, it is gone. The stage itself has been torn away. The Big Rip is frightening, yes, but it is also strange and beautiful in its logic. It shows how the same force that gently expands the cosmos today could one day unmake it. The quiet push that paints the night sky with drifting galaxies might, given enough time, pull every thread loose. It is the vision of creation undone, not by fire or collapse, but by stretching into nothing. Scientists do not know if the rip will come. It depends on the true nature of dark energy, and that remains one of the universe's deepest mysteries. If dark energy remains constant, the universe may fade into heat death instead. If it weakens, gravity might bring a big crunch. But if it grows stronger, if its push never stops, then the rip waits at the end of time. And if it comes, when would it arrive? Some models whisper of tens of billions of years. Others imagine longer stretches. No human eyes will see it. No stars alive today will endure to its end. It is a fate written far beyond the horizon of life. But still, the story is worth imagining, because it teaches you how fragile even the strongest things may be. There is a lesson here. The Big Rip shows that endings are not always outside us, crashing in like a wave. Sometimes they come from within, stretching gently until the bonds fail. A relationship, a memory, a universe, each can be undone not by sudden violence but by quiet, patient pressure. Close your eyes and picture it. A sky once filled with stars slowly emptying, galaxies unravelling like smoke in the wind, planets set free from their suns, atoms stretched thin until they dissolve into nothing. It is terrifying, yes, but also calm. There is no explosion, no scream, only silence, only distance growing wider until even the idea of together no longer exists. The Big Rip is the universe's loneliest ending. Heat, oh, death leaves upon them. The Big Crunch promises return. But the rip leaves nothing at all, so no closeness, no bonds, no stage. Just fragments too small to know they once belonged to something whole. And yet, even here in this strange and distant fate, there is a kind of beauty. For to imagine the rip is to imagine how much we depend on bonds. The bond of star to galaxy, the bond of planet to sun, the bond of particle to particle, the bond of life to life. Without them there is nothing. With them there is everything. Perhaps that is the gift of thinking about the Big Rip. It teaches you to see the threads that hold your own world together. The warmth of the sun, the pull of the earth, the closeness of others. These are your galaxies, your orbits, your bonds. They are fragile, yes, but precious because of it. So do not fear the rip. Let it remind you that even in the vast dark universe, connection is what makes meaning. The stars shine because gravity holds them. You shine because bonds of love, memory, and story hold you. The universe may one day fall apart, but here in this moment you are held. The fragile bubble. When reality itself collapses. Imagine the universe not as something solid, not as something permanent, but as a stage held up by invisible beams. These beams are not wood or steel. They are laws of physics that seem unshakable to us, but might not be eternal. You live your life trusting gravity to always pull you down, light to always shine, and time to always march forward. But deep beneath this comfort, there hides a strange possibility. The very vacuum of space, the empty background that holds everything, may not be the most stable form of reality. And if this is true, then our universe is only a temporary home, balanced on a knife's edge, waiting for one final slip. This idea is called vacuum decay, and it is one of the quietest, most chilling ways the universe could destroy itself. To understand it, you must step into the strangeness of quantum fields. Scientists believe that what we call empty space is not truly empty. It is filled with invisible fields, smooth, invisible blankets that cover the cosmos. Particles are not lonely dots, but ripples in these blankets. Every electron, every proton, every photon is a small wiggle in these fields. Among them is the Higgs field, which gives mass to matter, allowing stars, planets, and life to exist. Without it, nothing would hold together. The Higgs is like the quiet gardener of reality, keeping order in the cosmic garden. But what if the Higgs has not settled into the lowest, safest place it can be? What if it is perched on a false ledge, a hilltop disguised as a valley? Then one day, it might slip. This is the essence of vacuum decay. If the Higgs field is in what physicists call a false vacuum, then the universe is only pretending to be stable. One day, somewhere in the endless spread of galaxies, the field might collapse into a truer, deeper vacuum. This collapse would not spread slowly. It would happen in an instant, sparking a bubble of new reality. The bubble would grow at the speed of light, devouring everything it touched, rewriting the very laws of physics as it expanded. Inside the bubble, atoms could no longer exist. Stars would dissolve, life would vanish without even a chance to breathe. And because the bubble moves at light speed, you would never see it coming. One instant you are alive, reading, breathing, dreaming. The next instant, the laws of nature themselves have changed, and you are gone. It sounds like pure nightmare fuel, but in the hush of science, it is also oddly calm. Vacuum decay would be said, no flames, no shockwaves, no pain. Just a sudden curtain falling, erasing the stage entirely. In a way, it is the gentlest form of destruction. No struggle, no chaos. A simple transition from being to not being, like falling asleep without dreams. But why should anyone believe in such a strange possibility? The answer lies in the numbers of the Higgs boson, discovered in 2012 at CERN. Its measured mass, about 125 giga-electron volts, sits at an odd place, not too high, not too low, right on the edge between stability and instability. According to calculations, this might mean the Higgs is balanced precariously, as though our universe is living in a metastable state. Stable for now, but not forever. It is like walking on thin ice, not realizing the cracks are spreading beneath your feet. The timescales, though, are vast. Physicists estimate that if vacuum decay is possible, it may not happen for another 10 to the power of 100 years or more. That is a number so large it drowns the mind. Longer than the lifespan of stars, longer than black holes, longer than almost anything you can imagine. For now, the ice seems thick enough to hold us, but the possibility itself reshapes how we think about reality. It tells us that even the deepest, most trusted laws might not be eternal. The ground beneath existence is not concrete. It is glass. There is something strangely humbling in this thought. You are not standing on a permanent stage. You are floating on a bubble that could pop. And yet this fragile bubble has lasted for 13.8 billion years. Long enough for galaxies to form, long enough for stars to shine, long enough for Earth to blossom with forests, oceans and human beings who wonder about their place in the cosmos. Fragility does not mean weakness. Sometimes it means balance. If vacuum decay were to come, what would it feel like? You would not see a glowing sphere on the horizon. The horizon itself would vanish, swallowed by the bubble faster than your nerves could send signals. You would not feel fear. You would not even notice the change. The universe itself would simply replace you, rewriting every atom before your thoughts had time to form. In some sense, that makes this destruction softer than fire, quieter than ice, calmer than heat death. It would be a clean, silent ending. And yet, even in silence, the imagination trembles. What new laws of physics might reign inside the bubble? Would matter collapse instantly into dust? Or would exotic new structures bloom for a fraction of a second? Could there be particles and forces stranger than anything we know, flickering briefly in a newborn reality before it too dissolves? Perhaps there would be no time inside the bubble, no space, no possibility of anything resembling life. It would not be a place, it would be an absence. The most haunting part is this: if vacuum decay ever began, we would not be able to stop it. No machine, no technology, no intelligence could outrun or block a bubble moving at light speed. The fate of the universe would not be in our hands. We could only accept it. It is a reminder that there are scales of existence beyond our control, beyond our reach. We can split atoms, fly to other worlds, even peer into the birth of the cosmos. But we cannot stop the ground of reality from shifting if it chooses to shift. This is why vacuum decay feels like poetry as much as science. It is not only about the end of everything, it is about the fragility of being, about how something so immense, so eternal seeming, can rest on a hidden fault line. You wake each day under a sky of blue or grey, trusting it will always be there. But the sky is painted on glass, and glass can break. Still, there is comfort. For even if the Higgs is unstable, even if our universe is perched on a false vacuum, the time scales are unimaginably long. Longer than your life, longer than your children's lives, longer than the lifespan of the sun itself. For you, for us, this threat is only an idea, a shadow of a far-off possibility. The universe is fragile, yes, but it is also patient. It gives you time to live, to dream, to love, to wonder. Fragility and grace can exist together. So tonight, when you look at the stars, remember this. You are standing on thin ice, but the ice has held for billions of years. You are floating on a bubble, but the bubble has carried you through time. The possibility of collapse is not a reason for fear, it is a reason for awe, because it means you are here, alive, in a universe that allows you to exist at all, balanced on the quiet edge of forever. And perhaps, in the end, that is the strange beauty of vacuum decay. Not that it could erase everything, but that it shows us how precious everything is. The stars above, the ground beneath, the breath in your lungs, all of it is a miracle perched delicately on the fabric of reality. A fabric that might one day unravel, but for now holds you gently in its embrace. Proton decay, the slow unraveling of matter. Everything you see, everything you touch, even the air you breathe is made of atoms, and at the heart of every atom is the proton, a particle so small you could not see it even if you had a billion eyes. Protons have been around since the first seconds after the Big Bang, holding together the matter that became stars, planets, oceans, forests, and you. They are ancient and still, and yet the universe may have a secret plan for them. They might not last forever. This is the story of proton decay, a subtle, slow, and almost invisible way the universe could eventually unravel. At first, protons seem eternal. They have survived every supernova, every collision, every burst of cosmic radiation. They are the bedrock of matter. Without them, the universe would be nothing but a cloud of energy. But according to some theories in physics, grand theories that attempt to unify forces and particles, protons might be slowly breaking down. Not quickly, not tomorrow, but over unimaginably long times, far beyond the lifespan of stars, galaxies, or even black holes. Imagine a single proton quietly holding together an atom of hydrogen. For billions of years it sits stable, unchanging, a tiny anchor in the cosmos. And then, in a single quantum moment, it decays. It might split into lighter particles, a positron and a neutrino, and release a whisper of energy. Alone, the decay is imperceptible, silent, unnoticeable. But if every proton in every atom eventually decays, then matter itself will dissolve. Planets, stars, and galaxies will slowly vanish into radiation. The building blocks of reality will drift away, leaving emptiness in their wake. This process is not violent. There is no bang, no fire, no collapse. It is patient, slow, and indifferent. A hydrogen atom decays here, another there. Over unimaginable trillions and trillions of years, matter itself diminishes, particle by particle. The universe does not explode, it simply thins. The stage that once held life, that once held stars, shrinks quietly into invisible threads of energy. You can imagine the Earth, once rich with forests and oceans, slowly losing its atoms. Mountains crumble into dust, oceans fade into clouds of radiation, and all the life that once thrived dissolves in a timeless, patient evaporation of matter. The sun itself, once a blazing heart of light, becomes nothing more than scattered energy as its protons decay. Over eons, the cosmos grows emptier, quieter, colder. What is strange about proton decay is its patience. Unlike a supernova that explodes suddenly, or a black hole that swallows instantly, this destruction is invisible. There is no warning. It unfolds on a scale beyond imagination, stretching over time so long that human thought cannot comprehend them. Even the most patient stars, even the longest-lived red dwarfs, will ultimately vanish as their atoms decay. The universe will become a ghostly place, a quiet ocean of radiation drifting across a vast dark expanse. And yet, in this slow unravelling, there is something oddly beautiful. It reminds you that even the tiniest particles, the building blocks of reality, have their own story. They are not eternal, but their decay is gentle, like leaves falling from an ancient tree or sand slipping slowly through an hourglass. The universe teaches you to see time not as a rush, but as a long, patient unfolding where endings can be quiet and graceful. Even now you are surrounded by protons, the same ones born in the first moments of the cosmos. Every atom in your body carries the memory of the Big Bang. Your hands, your heart, your thoughts are built from particles older than the Earth itself, and yet every particle carries the possibility of ending. It is a subtle reminder that life, matter, and even the universe are fleeting. Not in panic, not in sudden fear, but in the slow, inevitable patience of time. Proton decay also teaches us about resilience. For billions of years, protons have endured cosmic violence, exploding stars, black holes, cosmic rays, and collisions that span light years. They have held matter together through every epoch. Their eventual decay is not failure. It is simply the next chapter in a universe that moves forward, patient and unhurried. If proton decay does occur, the universe will not notice the change in a human lifetime. It will be a whisper across cosmic time, a gentle fade that no eyes can see. Yet, in this tiny, patient destruction, the cosmos continues to tell its story. Even in endings, there is order, there is rhythm, there is the slow poetry of existence unravelling. You can picture a star cluster in the far future. Once bright and sparkling, it now drifts quietly in darkness. The atoms that once burned in fusion slowly dissolve into energy. The light fades, the warmth disappears, and yet the pattern remains. Even in the absence of matter, the universe preserves the memory of what was, the paths of galaxies, the echoes of radiation, the gentle hum of space-time itself. Proton decay reminds you that even permanence is temporary. Every mountain, every ocean, every particle will one day be gone. And yet the story of the universe continues. Space stretches, time flows, and the gentle rhythm of physics persists. Even without matter, even without stars, the cosmos moves forward. A slow dance of emptiness and energy, quiet and patient, as if teaching you that even endings have grace. Perhaps that is why we study these possibilities, to remind ourselves of the fragility of all things, to marvel that despite impermanence, stars shine, life blooms, and consciousness wonders. You exist in a universe balanced on the threads of time and matter, a fleeting, precious moment in a vast and patient cosmos. Proton decay is the quiet song of the universe's end, but for now the song is still playing. So close your eyes and imagine the far future. The galaxies have thinned, stars have faded, the last atoms tremble in space one by one, decaying into nothing. The universe has grown silent, empty and cold, and yet Somewhere in that silence, you can sense the echo of what was. The cosmos, fragile and patient, continues its slow dance, teaching you that even in decay there is beauty, even in endings there is poetry, even in emptiness there is wonder. Black hole evaporation, when darkness finally fades. Black holes are often thought of as the ultimate prisons of the universe, dark wells where nothing escapes, not light, not matter, not even hope. They are the shadows in the cosmic landscape, mysterious and eternal. For eons they swallow stars, dust, and anything that drifts too close, growing heavier, stronger, and darker. Yet even these mighty kings of gravity are not eternal. Over unimaginable stretches of time, black holes too can fade, evaporating into nothing. This process, called Hawking radiation, is a gentle, strange, and poetic ending to the most powerful objects in the cosmos. To imagine black hole evaporation, picture a star so dense that its gravity bends space itself. Light cannot escape its pull, so it glows no more. Around it, space twists, creating a sphere of darkness that seems unbreakable. You might think that nothing could ever touch it, that it will last forever, and for many billions of years it might seem so. But even a black hole is not immune to the quiet rules of quantum physics. Tiny fluctuations, the ghostly dance of virtual particles that appear and vanish in empty space, slowly steal energy from its edges. This is Hawking radiation, the whisper of the universe against the mightiest darkness. It is not violent. You cannot see it with your eyes. You cannot feel it with your hands. But over time so vast they defy imagination, this whisper carries away mass from the black hole. Bit by bit it leaks, shrinking imperceptibly. A black hole that once devoured entire stars will slowly grow lighter, its shadow thinning, its gravity weakening until the darkness itself begins to fade. Imagine a black hole at the centre of a distant galaxy. For millions of years it has held its kingdom, swallowing gas, dust, and wandering stars. Over trillions of years, Hawking radiation begins its work. Tiny particles escape from the event horizon, carrying away an infinitesimal amount of energy. At first, nothing seems to change. The galaxy spins, the stars shine, and the black hole's darkness appears unbroken. But time stretches over unfathomable eons. The slow leakage accelerates. The black hole shrinks, its hunger diminishes, the shadows that once defined it waver. Eventually, even the largest black holes, the supermassive monsters at the hearts of galaxies, will reach the end of their long, patient lives. They will evaporate completely. Their mass will dissipate into radiation, a final glow that is bright for a brief instant in the vast darkness of space. And then, even this last light will vanish. The universe will have lost one of its most powerful forces, quietly and peacefully. This process is remarkable because it shows that even the darkest, densest, and seemingly eternal things have a gentle end. Nothing in the cosmos can resist the passage of time forever. Stars burn, galaxies collide, protons decay, black holes evaporate. Even the strongest, the heaviest, the most terrifying objects eventually succumb to the patient rhythm of the universe. There is a strange comfort in this, a reminder that impermanence is universal, and yet black hole evaporation also transforms the universe. When the shadows fade, the energy they held is released. It spreads across the cosmos, carrying the memory of everything that the black hole once swallowed. The stars it devoured, the planets it consumed, even the dust of ancient civilizations that drifted too close, all are returned to the universe as gentle radiation, spreading thin and quiet across space. Nothing is destroyed. It is only transformed, returned to the cosmic dance in a new form. This process also teaches patience. Black holes last far longer than stars, far longer than galaxies. Their lifetimes stretch across tens of trillions of years, sometimes hundreds of trillions, dwarfing the lives of humans and even civilizations by numbers we cannot truly comprehend. Their evaporation is slow, imperceptible, and silent, a cosmic rhythm beyond fear, beyond notice, yet inevitable. The universe reminds us that even the seemingly permanent will change, and that change can be both gentle and inevitable. Imagine, in the far future, a universe where stars have faded, galaxies are dark and empty, and protons have decayed. The last black holes linger as the final kings of the cosmos. Slowly, gently, they release their hold, evaporating into nothing. Space, once twisted and warped, becomes flatter, quieter, emptier. Radiation drifts in all directions, carrying the echoes of long-vanished worlds. Light itself becomes a memory. Even in this vast emptiness there is beauty. There is poetry in the idea that darkness itself can fade, that the most powerful forces in the cosmos are subject to the patient rules of time. Black hole evaporation teaches humility. It teaches awe. It teaches that endings can be calm, quiet, and transformative rather than violent and destructive. The universe is not cruel, it is patient, balanced, and deeply poetic. And so, when you imagine black holes, do not see only the darkness. See also the slow, patient glow that eventually returns to the universe. See the gentle inevitability of change. Even the darkest things, like shadows and mysteries, carry within them the seed of their own transformation. This is one of the quietest, most profound endings of all. The fade of darkness, the return of energy, the continuation of the cosmic dance in a universe that is patient, gentle, and eternal in its rhythms. Black hole evaporation is the universe's whisper, a reminder that time touches everything. It does not destroy with anger or fire. It simply flows, gently unmaking what once seemed permanent, returning it to the vast, quiet sea of existence. Even in the farthest reaches, in the silence beyond the stars, the universe continues its calm, eternal song. And in this, there is hope. Even as the cosmos dims, even as matter dissolves and light fades, the energy released by black hole evaporation spreads warmth, a quiet echo of all that came before. The universe may be empty, yet it is not meaningless. Even in endings there is continuity. Even in darkness there is gentle light. Cosmic expansion forever. The endless stretch. The universe is vast, but it is also growing. Galaxies are not only moving apart, they are accelerating, drifting faster and faster into the darkness. This endless stretch of space is one of the quietest, most poetic fates the cosmos might face. Imagine the universe as a great invisible balloon, expanding forever, carrying galaxies, stars, and planets on its surface. For billions of years it has grown, and it may never stop. This is the vision of cosmic expansion forever, a fate both serene and haunting. At first, the expansion seems gentle. Galaxies drift slowly apart, barely noticeable to anyone looking from a single point in space. Stars still burn, planets still orbit, and life continues in familiar patterns. But over time, the distances grow enormous. Light struggles to bridge the gaps. Galaxies become isolated islands in a dark sea, their neighbours disappearing from view as space itself stretches between them. This expansion is powered by a mysterious force, dark energy. Invisible and pervasive, dark energy acts like a cosmic wind, pushing the universe outward. Unlike gravity, which pulls objects together, dark energy works against it. It seems constant, relentless, unstoppable. And if it continues forever, the universe will grow colder, emptier, and more silent with every passing eon. Imagine standing on a distant planet, looking up at the night sky. Today, you see countless stars, countless galaxies shining across the darkness. In the far future, you might see only your galaxy, lonely and isolated. Neighbouring galaxies will have moved beyond reach, their light stretched so far that it can never reach your eyes. The universe becomes a quiet, empty ocean of darkness, where motion slows and distances stretch endlessly. Even stars are affected. Over unimaginable time, star formation will cease as the gas required for new stars is exhausted. Existing stars will burn out, leaving white dwarfs, neutron stars and black holes drifting alone in expanding space. Radiation thins, temperatures drop, and the cosmos grows silent and cold. Planets freeze, oceans vanish, and life, if it still exists, huddles in the last pockets of warmth. Yet the expansion is calm, almost gentle. There is no explosion, no crash, no sudden catastrophe. It is slow, subtle, patient. It stretches the universe like taffy, widening distances, stretching light, and spreading energy ever thinner. Everything becomes isolated, quiet, distant. The universe itself seems to yawn, expanding outward in endless slowness, as if the cosmos is taking a timeless breath. Over trillions of years, even the bonds of galaxies weaken. Gravity can no longer hold clusters together against the relentless push of space. Groups of stars drift apart, leaving single stars adrift in the vast emptiness. Cosmic structures that once seemed permanent dissolve, leaving only a thin, cold web of isolated matter in a sea of darkness. The expansion forever is a meditation in time. There is no panic, no urgency. The universe simply grows, carrying matter along with it, stretching distances, thinning energy, and slowing motion. It is a gentle reminder of the impermanence of all things, a quiet lesson that nothing stays close forever, that isolation is inevitable, and yet the cosmos continues its patient rhythm. Even the very fabric of space seems to whisper. Space expands between atoms, between stars, between galaxies. Distances that seem unthinkable today become normal. Light itself becomes stretched, redder and dimmer, until it is barely perceptible. The universe glows faintly with the last traces of radiation, a soft cosmic twilight spreading across endless dark. And yet there is a beauty here. In isolation, in emptiness, in the endless stretch, there is clarity. There is a rhythm, a cosmic patience that teaches awe. Galaxies drift apart not because of destruction, but because of the natural, inexorable flow of space-time. Time stretches, space stretches, and the universe continues its silent, majestic dance. Even if the universe expands forever, there is continuity. Energy spreads thin, but it does not vanish. Particles drift across the vastness, the memory of creation preserved in radiation, in lingering light, in the quiet pulse of existence. The cosmos teaches that even in solitude, even in isolation, there is presence. Even in emptiness, there is the echo of what once was. Close your eyes and imagine this far future. The galaxies are distant, the stars sparse, the sky nearly dark. The universe continues to stretch, patient and unhurried, carrying remnants of light, fragments of matter, and memories of cosmic motion across the endless void. Time itself flows, even as distances expand beyond imagination. And in this quiet, calm, endless stretch, there is a sense of peace. The universe does not end with a bang or a rip, continues, patient, silent, infinite, and strangely beautiful. Cosmic expansion forever is a reminder of the vast patience of the universe. It is the gentle stretching of everything we know, a quiet unfolding into eternity. There is no rush, no sudden end, just motion, calm, patient, inevitable. And in this, the universe teaches a final lesson, that endings can be subtle, that time can be vast beyond reckoning, and that even in isolation there is profound beauty. Stellar collapse, the last glow of stars. Stars are the jewels of the universe, shining bright against the black canvas of space. They live, they burn, they give warmth and light to everything around them. And yet every star has an ending. No matter how massive, how powerful, or how eternal it seems, the laws of physics dictate a final chapter, a quiet, inevitable collapse into darkness. This is the story of stellar collapse, the last glow of stars before they fade from the cosmic stage. Imagine a star like our Sun. For billions of years it burns with steady grace, fusing hydrogen into helium, releasing energy that warms planets and lights the sky. Its life seems endless to human eyes, but over cosmic time the fuel runs out. The nuclear fires that hold the star's core aloft begin to weaken. Gravity, patient and unrelenting, starts to pull inward. The star wobbles, contracts, and begins a slow, inevitable descent toward its final form. For smaller stars, the process is quiet and gentle. They shrink into white dwarfs, dense cores the size of planets but heavier than the sun. Their light dims over trillions of years, fading into cool, silent embers. No explosion, no dramatic flare. Just a slow, patient dimming, a quiet disappearance of warmth and glow. Even in this fading there is grace. The star does not vanish abruptly. It leaves a memory in the space around it, a ghost of light that travels across the cosmos long after the core has cooled. Massive stars, on the other hand, have a more dramatic ending. When their fuel is exhausted, their cores collapse rapidly, and their outer layers explode in a brilliant supernova. For a brief instant, they outshine entire galaxies, releasing energy and scattering heavy elements into the void. These elements, forged in the star's heart, seed new generations of stars, planets, and even life. In the destruction of one star lies the creation of many. The universe recycles itself patiently like a slow, enduring rhythm. Some massive stars leave behind neutron stars, tiny spheres of unimaginable density, where a teaspoon of matter weighs billions of tons. Others collapse further, forming black holes, those mysterious wells of gravity we spoke of earlier. Each ending is different, but each carries the same lesson. Even the brightest, most enduring lights are temporary. They burn, they shine, they fade, and in their fading they teach us patience, impermanence, and beauty. Over time, trillions of years from now, the universe's stars will dwindle. Red dwarfs, the most common stars, will burn for trillions of years, quiet and steady, but eventually they too will fade. White dwarfs will cool into black dwarfs, cold and dark, leaving the universe ever more silent. Galaxies will grow dim, and the night sky will lose its sparkle, leaving only distant, faint glows and scattered remnants of energy. Yet even as the stars collapse, there is continuity. The matter they leave behind, the carbon, oxygen, iron, and other elements, continues to drift through space, carried by gravity, recycled into new forms. Stars are temporary, but the universe remembers them. Their light, their energy, their matter, everything becomes part of the eternal flow of cosmic history. In a way, even in their death, stars persembore. Imagine, in this far future, standing on a quiet planet or drifting through interstellar space. No bright stars shine overhead. The sky is mostly dark, yet faint glimmers remain, the echoes of billions of stars long extinguished, travelling across the vast distances of space. These glimmers are a testament to the patient, enduring rhythm of the cosmos, a universe that burns, fades, and remembers. Stellar collapse also reminds you of scale. Human life is brief, fleeting, almost imperceptible. Even civilizations last a blink compared to the lifespan of stars. Yet the patient rhythm of stellar evolution offers perspective. Time is long, endings are slow, and the universe moves in a quiet, measured flow. Every star, every galaxy, every particle follows this rhythm, unfolding over spans that dwarf imagination. In the very final chapters, the universe becomes darker, colder, quieter. Black dwarfs drift, neutron stars rotate silently, and black holes linger as the last remnants of stellar evolution. The cosmos is no longer filled with the warmth of young stars or the brilliance of exploding giants. Instead, it becomes a quiet, patient expanse, filled with the memories of what once was, the energy of what once burned, and the faint whisper of light that continues to travel across space. And there is a strange comfort in this vision. The stars burn, the stars fade, but the universe endures. Life may be gone, planets may be cold, but the cosmos moves forward in its patient, endless rhythm. Stellar collapse is not chaos or destruction. It is the gentle folding of one chapter into the next, a quiet conclusion that makes space for what comes after. Even in endings, there is poetry. Even in darkness, there is memory. Stars teach that impermanence can be beautiful, that endings can be calm, and that the universe itself is patient, elegant, and profoundly gentle. Each collapse is a whisper, quiet note in the endless song of cosmic time, reminding us that all things, however grand or small, participate in the flow of existence. Close your eyes and picture this far future. The last stars glow faintly, then fade. Their warmth drifts into cold space. The cosmos becomes quiet, empty, and still. And yet, in that stillness, you can sense the rhythm of time, the memory of creation, and the patient, gentle unfolding of a universe that moves always toward the next chapter. Galactic decay. When galaxies drift apart, galaxies are the grand cities of the universe, islands of stars, planets, gas and dust bound together by the invisible threads of gravity. They spin in elegant dances, spiral arms stretching across thousands of light years, holding billions of suns in quiet harmony. Yet even these mighty structures are not eternal. Over unimaginable time, galaxies themselves face decay, slowly drifting apart as the universe stretches, leaving the cosmos lonelier and quieter than ever before. At first, galactic decay is almost imperceptible. Stars continue their orbits, clusters remain bound, and the night sky remains luminous with countless suns. But space is expanding, and dark energy, the invisible, persistent force driving this expansion, gradually begins to pull galaxies away from one another. Clusters of galaxies, once tightly knit, loosen their bonds. The dance of gravity that held neighbours close starts to falter. The cosmic web thins, and galaxies drift ever farther into isolation. Picture the Milky Way, our home galaxy, surrounded by the local group of galaxies. In the far future, billions of years from now, neighbouring galaxies like Andromeda will no longer approach or collide. They will recede, carried away by the relentless expansion of space. Eventually, the Milky Way will become a solitary island of stars, distant and dark, its companions lost to the widening void. The universe will feel emptier, quieter, lonelier, but also strangely calm, a vast ocean with a single drifting vessel. Within galaxies, decay is subtle, yet profound. Stars continue to age and die. Gas clouds for new stars dwindle, leaving only aging populations of long-lived stars. Over trillions of years, black holes, white dwarfs, and neutron stars dominate, surrounded by an expanding emptiness that grows more pronounced with every passing eon. Galactic structures lose cohesion, clusters scatter, and the once vibrant cosmic cities fade into the background of space. Some galaxies may experience collisions and mergers along the way, dramatic events that rearrange stars and reshape structures. But in the ultimate sweep of cosmic time, even these interactions are temporary. The expansion of space, though slow at first, eventually dominates. Gravitational bonds are stretched thinner and thinner until galaxies themselves can no longer hold together. Stars are flung into intergalactic space, drifting alone in the darkness, remnants of civilizations that never existed. Galactic decay is not violent. There is no roar, no explosion, no sudden loss. It is patient, gradual, and silent. The universe teaches a subtle lesson here. Endings need not be sudden or chaotic to be complete. Even the largest, most magnificent structures, containing billions of suns, are not immune to time. Everything, no matter how massive, eventually succumbs to the patient, gentle forces of the cosmos. Imagine floating in intergalactic space far in the future. The night sky is sparse. Only the faint glow of your galaxy illuminates the darkness. Neighbouring galaxies, once visible and radiant, have drifted beyond reach. The universe is quieter, lonelier, yet still beautiful. Each isolated star, each scattered cluster tells a story of resilience and impermanence, a reminder that even in decay, there is elegance. Galactic decay also teaches perspective. Human life, even the lifespan of entire civilizations, is inconceivably brief against the timescales of galactic evolution. Entire galaxies live, age, and fade, while countless generations rise and fall on planets like Earth. Observing this slow, inevitable drift evokes humility and wonder, a sense of awe for the patience and scale of the universe. Over trillions of years, as galaxies drift apart, the cosmic landscape becomes quieter still. Star formation ceases almost entirely, leaving only the fading remnants of older stars. Black holes, the last gravitational anchors, persist but cannot prevent the ultimate isolation. Clusters dissolve, stars wander freely, and the universe becomes a cold, lonely, but strangely poetic expanse. And yet, even in this emptiness, there is continuity. Energy persists, radiation drifts across space, and the laws of physics continue their patient dance. Galactic decay is not an end, but a transformation, a quiet transition from complexity to simplicity. The universe moves forward, patient, calm, and indifferent to human concerns, yet profoundly graceful in its process. Close your eyes and imagine this far future. The Milky Way drifts alone, surrounded by darkness. Neighbouring galaxies are gone, scattered across a space that has grown unimaginably vast. Stars burn dimly, black holes linger silently, and the cosmos stretches on, infinite and quiet. In this, there is a strange comfort. Even as structures fade, even as isolation grows, the universe continues its patient rhythm, a gentle, enduring song across the endless void. Galactic decay reminds us that endings are part of the natural flow. Isolation, emptiness, and quiet are not threats. They are expressions of the cosmos's patient, unhurried evolution. Even as galaxies drift apart, there is poetry, grace, and continuity. The universe, in its endless expansion, shows that even in the absence of warmth, light, or life, there is rhythm, there is order, and there is a calm beauty that stretches forever. Cosmic chill. The universe grows cold. Imagine drifting through the cosmos billions and trillions of years from now. Galaxies have thinned, stars have faded, and the universe has grown lonely. The warmth of starlight, once so abundant, has become a rare treasure. Slowly, almost imperceptibly, the universe enters a stage known as the cosmic chill, a time when temperature drops, motion slows, and the energy that once made the cosmos vibrant becomes faint and distant. At first, the chill is subtle. Stars continue to burn, clusters remain partially bound, and pockets of warmth survive in dense regions. But as expansion stretches space ever further, radiation thins. Light takes longer to reach distant corners, and energy spreads across ever-increasing distances. Even the tiniest particles of heat lose their strength. The cosmos becomes colder with every passing eon, a slow, patient descent into darkness and silence. This chilling of the universe is not violent. There is no freezing storm, no sudden catastrophe. It is patient, like winter creeping across a vast landscape, touching everything gently, evenly, without hurry. Even the remnants of galaxies, black dwarfs, neutron stars, and isolated white dwarfs, cool steadily, their internal heat slowly radiating away into the void. Temperatures drop toward absolute zero, the lowest possible energy state where motion itself becomes minimal, and the universe approaches a state of stillness. Imagine standing on a lonely frozen planet in this far future. The air, if there is any left, is thin and cold. Stars are faint and distant, their warmth reduced to mere whispers. Even light from neighbouring galaxies, if any remain visible, has dimmed to a ghostly glow. The universe is vast, empty and patient, a quiet expanse where the echoes of energy stretch thin across the darkness. Over unimaginable time, matter and energy become evenly distributed. Black holes evaporate, stars cool, and radiation thins. Motion slows. Chemical reactions that once powered life cease. Even atomic activity, the subtle vibration of particles, is diminished. The universe has become a slow, silent and cold expanse, a place where the once vibrant dance of matter and energy has entered a near eternal rest. And yet, in this chill, there is poetry. The universe does not end abruptly. It does not scream or collapse. Instead, it becomes patient, calm and serene. Space stretches, temperatures fall, and energy diffuses across vast distances. This is the gentle end of thermal motion, the quiet fading of heat and light, a transition that feels almost meditative. The universe is empty, yes, but also profoundly elegant, a grand canvas of silence and stillness. Even the processes of decay and fading carry beauty. Stars that once burned brightly leave behind white dwarfs, slowly cooling into black dwarfs. Black holes, once devouring everything nearby, evaporate into Hawking radiation, releasing the last traces of energy in subtle glows. Even isolated particles drift across the cosmos, carrying faint memories of heat and motion. There is no chaos here, only the patient rhythm of entropy, a gentle reminder that time flows inexorably forward. Cosmic chill is also a lesson in impermanence. The warmth, light, and activity we take for granted are temporary. The universe once vibrant with stars and life slowly cools into silence. Yet this impermanence does not diminish wonder. Instead, it enhances it. The fact that warmth and motion existed at all, even for billions of years, is a miracle in the vast, patient scale of cosmic time. Picture the universe now as it continues to grow colder. The few remaining stars shine faintly, their light stretching thin across distances that no longer allow interaction. Galaxies drift apart. Cosmic background radiation, the afterglow of the Big Bang fades further, leaving an almost featureless cold darkness. The universe, once lively and bright, has become a quiet, frozen expanse, a serene and solemn testament to the passage of eons. And yet, even in this cold there is continuity. Energy persists, however faintly. The laws of physics remain, guiding the slow dance of particles, radiation, and space. Even in near absolute zero, motion continues at the quantum level. Entropy spreads, but it is gentle. The universe, though cold and quiet, is not lifeless in principle. It remains structured, orderly, and profound in its silence. Close your eyes and imagine drifting through this frozen expanse. The stars are dim, galaxies are distant, light is stretched thin, motion is slow, and heat is a rare visitor. Yet the cosmos continues, patient, quiet, and eternal. The chill teaches awe, humility, and a deep sense of calm. Even as the universe grows cold, there is beauty, rhythm, and the profound elegance of cosmic time stretching forever. The cosmic chill reminds us that even the grandest, warmest, and most active objects are temporary. Nothing in the universe can resist the patient, inevitable flow of time, but even in endings there is serenity. Even in darkness there is poetry. The universe grows cold, yes, but it does so with calm, patience, and grace, revealing the subtle, quiet beauty of existence at its most extreme and enduring. As the universe grows colder and older, space itself begins to dominate over matter. Galaxies have drifted apart, stars have faded, and even black holes have vanished through patient evaporation. What remains is an almost empty expanse, a cosmos where the distances between particles are vast, almost unimaginable. This is the darkness between particles, a stage where the universe is near empty, quiet, and extraordinarily lonely, yet strangely poetic in its emptiness. At first, the emptiness is subtle. Particles still exist, protons, neutrons, electrons, but they are rare. Most atoms are locked in distant remnants of galaxies, slowly cooling white dwarfs or wandering lonely stars. Radiation is faint, energy is sparse, and motion is minimal. The universe is no longer a bustling network of stars and galaxies. It is a silent sea, where even light must travel unimaginable distances before encountering matter. Imagine drifting through this universe. You would see nothing for millions of light years. The nearest particle might be so distant that it would take an eternity of travel just to reach it. Empty space dominates, a vast ocean of silence, stretching between the few remaining fragments of matter. And yet in this emptiness there is structure. Quantum fluctuations, ghostly fields, and the faint echo of the original Big Bang still ripple across space, subtle, almost imperceptible, but persistent reminders of the cosmos's ancient past. Particles themselves begin to behave differently in such emptiness. Freed from the pull of stars, galaxies, and dense matter, they drift alone, influenced only by weak gravitational forces or rare collisions. Even light, stretched thin by cosmic expansion, travels vast distances before interacting with anything. The universe has become a quiet, patient, nearly static place, where events occur over timescales so long they challenge comprehension. In this near-empty cosmos, the energy that once animated life, stars, and galaxies has become diffuse. Radiation drifts like a faint breeze, matter is rare, and temperature hovers near absolute zero. The universe has transformed from a crowded, vibrant space into a calm, sparse expanse. It is a universe where endings are quiet, and every remaining particle is a relic of immense history, a memory of creation itself. Even in near emptiness there is subtle beauty. The tiny distances between particles are vast in human terms, yet each particle carries the imprint of billions of years of cosmic evolution. Protons and neutrons that survived the earliest moments of the universe continue to exist, remnants of the Big Bang, travelling alone through a silent frozen void. Even in the absence of light and warmth, the cosmos retains order, structure, and a patient, unhurried rhythm. This stage of the universe teaches humility. Human life, planets, civilizations, even stars and galaxies are tiny flickers compared to the near-eternal span of emptiness. The universe continues its slow march, indifferent to our concerns, yet profoundly poetic in its patient unfolding. The distances between particles are reminders that even the smallest pieces of matter are part of a vast, interconnected story stretching across time and space. The emptiness also offers a strange comfort. With no violent events, no sudden destruction, and no cosmic chaos, the universe is calm. Particles drift without collision, radiation spreads thinly, and space itself seems to breathe slowly, evenly. Time stretches, almost motionless, as the last fragments of matter glide across the quiet void, moving in accordance with laws that are gentle, precise, and eternal. Imagine in this far future reaching the edge of known matter, you see only blackness, a nearly perfect vacuum punctuated by the occasional solitary particle. There are no galaxies, no stars, no warmth. Yet the universe is not lifeless. It hums quietly with the faintest quantum fluctuations, the dim radiation that remains, and the subtle pull of gravity stretching across vast distances. It is empty, yes, but alive in principle, a silent testament to the patient flow of time. The darkness between particles is a meditation on impermanence and continuity. Even as stars burn out, galaxies drift apart, and cosmic energy spreads thin, the universe preserves its order. Every particle, every photon, every quantum fluctuation carries a trace of history, a memory of all that came before. The cosmos has transformed into an almost empty expanse, but its story is not over. It continues in the patient motion of its tiniest constituents. Close your eyes and imagine drifting in this near-empty universe. Vast distances separate every particle. Silence dominates. Cold, still, patient emptiness stretches endlessly in all directions. Yet the universe moves forward, gentle, calm, and eternal. In this there is beauty. Even when the universe is almost nothing, it remains poetic, ordered, and profoundly quiet, a serene testament to the long, patient unfolding of cosmic time. The last photon, fading light across eternity. Light has always been the heartbeat of the cosmos. It travels across space, carrying warmth, energy, and information. From the first glow of newborn stars to the faint remnants of ancient galaxies, photons, tiny packets of light, have illuminated the universe. Yet even light is not eternal. Over unimaginable eons, as galaxies drift apart, stars fade, and cosmic expansion stretches space, photons themselves will become the last whispers of a dying universe. This is the story of the last photon, a journey of light fading across eternity. At first, photons move freely, unburdened by gravity or matter. They traverse space, connecting stars, galaxies, and planets. Their journeys span millions and even billions of years, crossing distances that defy human comprehension. Each photon carries the story of its origin, a star's birth, a supernova's explosion, or the afterglow of the Big Bang itself. They are messengers of cosmic history, silent and persistent, travelling through darkness with unwavering patience. As the universe ages, photons begin to stretch. Cosmic expansion elongates their wavelengths, transforming visible light into infrared, then radio waves, and finally into a nearly imperceptible hum of energy. The warmth they once carried diminishes. The light of galaxies grows faint, distant, and eventually invisible to any observer. Yet even as they fade, photons remain. They are the lingering echoes of the universe's vibrant past, drifting across space with an almost meditative quiet. Imagine a photon leaving a star in the early universe. It journeys for billions of years, passing through clouds of gas, swirling galaxies, and the empty reaches between clusters. Over time it is stretched, its energy reduced, its colour altered. It passes planets, asteroids, and perhaps even civilizations that have long since vanished. It is the last witness to a cosmos that once teemed with warmth and light, and yet it continues, faithful to its path, a solitary traveller in a quiet, expanding universe. Eventually, the last photons face the ultimate challenge, the darkness of near-empty space. With matter sparse and galaxies isolated, there are fewer interactions, fewer opportunities to scatter, reflect, or be absorbed. They drift alone, travelling across unimaginable distances, stretched thinner and fainter with every passing eon. The universe becomes colder, emptier, and the light becomes a ghost, almost imperceptible against the vast black canvas of space. Even as photons fade, they carry memory. The energy they once held is not lost, it is transformed, diluted across the expanding cosmos. Each photon embodies the story of creation, of stars that burned and planets that formed, of atoms that drifted through the void. They are the last threads connecting the present to the deep history of the universe, a quiet bridge between what was and what will be. This fading of light is not violent or abrupt. There is no explosion, no clash, no end. It is patient, subtle, and almost imperceptible. The last photons move according to the gentle rules of physics, following trajectories written at the dawn of time. They teach us patience, impermanence, and the beauty of gradual change. Even as the universe grows dark, light persists, reminding us of all that once was. Imagine drifting alongside the last photon. Space is vast and empty. The nearest star is billions of light years away, long faded. Radiation is thin, temperature is near absolute zero, and matter is rare. Yet this photon continues its journey, a solitary traveller carrying the legacy of cosmic history. It moves silently, patiently, faithfully, across an almost endless void. Even in this fading there is poetry. The universe is not cruel or indifferent. It does not snuff out light abruptly. Instead, it allows photons to travel, to witness, and to carry memory across eternity. The last photon teaches that even endings can be gentle, that even the disappearance of stars can be a quiet, meditative process, and that the cosmos moves forward in a calm, orderly rhythm, no matter how empty or cold it becomes. As time stretches further, the last photon approaches the limits of perception. Its energy diminishes into near nothingness, yet it still exists in principle, a witness to all cosmic history. The universe, once vibrant and full of life, has become an almost perfect void, yet light continues to drift through the darkness, patient and eternal in its own way. Close your eyes and imagine this far future. The sky is black, almost absolute. Only the faintest glimmers of photons drift across space, each carrying stories of stars and galaxies long gone. They are quiet, calm and serene, stretching across eternity. And in this silence you can sense the poetry of light, the patient rhythm of the cosmos, and the gentle, enduring memory of the universe itself. Even as the last photon fades, the story of the universe continues. Light may diminish, stars may vanish, and matter may disperse, but the cosmos moves forward, calm, patient, and eternal. The last photon is a reminder that even in endings there is continuity, beauty, and the gentle unfolding of cosmic time. Quantum whispers, the smallest echoes of the universe. Even as galaxies fade, stars collapse, and the last photons drift across the cold void, the universe is never truly silent. At scales far smaller than we can see, at the edges of matter and energy, subtle movements continue. These are the quantum whispers of the cosmos, tiny echoes that persist even in the most empty, frozen reaches of space. They are the softest reminders that the universe never truly rests, even when it seems dark, quiet, and still. Quantum mechanics governs the realm of the very small particles, fields, and forces that shape reality itself. Even in near-empty space, fluctuations occur. Particles appear and vanish spontaneously. Energy jitters in tiny bursts, and the vacuum itself hums with unseen motion. These whispers are imperceptible to human senses, but they are real, a constant, patient background to the cosmic silence. Imagine a region of space where a single particle drifts alone. Around it, the vacuum is alive in subtle ways. Virtual particles appear momentarily, borrowing energy from the void and disappearing again, leaving tiny ripples in the fabric of space-time. These are the universe's soft murmurs, the quantum echoes of existence itself. Even when stars have vanished, even when matter is sparse, these whispers persist, gentle yet relentless. Quantum fluctuations are more than idle motion. They carry energy, influence, and possibility. They may subtly shift the paths of drifting particles, provide the seeds for rare events, and preserve the rules of physics long after the bright activity of stars and galaxies has ended. In this sense, even in a universe that seems empty and cold, there is still movement, still life at a scale beyond comprehension. Imagine floating through this silent, near-empty universe, noticing the almost imperceptible jitter of particles. You cannot see it with your eyes, but it is there, the universe breathing quietly at the quantum level. Each fluctuation is a gentle note in the vast, ongoing symphony of existence. Even in near absolute zero, the universe whispers softly, endlessly, reminding us that nothing is truly static. These quantum whispers also preserve possibility. In the deepest, coldest corners of space, rare events may still occur. Two particles might meet after trillions of years. Energy may be redistributed. Tiny sparks of motion ripple outward. Though the universe is vast and mostly empty, the potential for subtle change remains. This is the patient, eternal heartbeat of the cosmos, continuing long after stars, galaxies, and photons have faded. The poetry of quantum whispers lies in their quiet persistence. They operate on scales invisible to humans and yet underpin everything in existence. The universe, no matter how empty or cold, continues to move at its smallest levels. These fluctuations may be subtle, but they are constant, like a soft pulse beneath the stillness of a vast sleeping ocean. Even in this far future, when the universe has entered its final stages of cooling, quantum whispers ensure that nothing is ever truly dead. They preserve the memory of matter, energy, and the laws of physics, and they maintain a kind of quiet order that endures across unimaginable stretches of time. They are tiny, gentle echoes, but they are fundamental, woven into the fabric of reality itself. Imagine drifting alongside these quantum movements, aware that even in a universe almost devoid of light, heat, and matter, there is a subtle, persistent song. Each fluctuation is a note in the infinite composition of existence, a reminder that the cosmos never completely ceases. It whispers, softly, patiently, eternally. Quantum whispers are the final hum of a universe that has grown cold and empty, a delicate testimony to the persistence of structure, motion, and possibility. Even when cosmic light has vanished and matter is sparse, these soft echoes endure. They are the tiniest, gentlest heartbeat of a universe that moves forward quietly, endlessly, and with subtle, ineffable grace. Close your eyes and imagine these whispers stretching across space and time. The universe is mostly dark and still, yet, at the smallest scales, it is alive, softly vibrating, infinitely patient. Even as the cosmos approaches its ultimate fate, these quantum murmurs remind us that movement never truly ends, that existence persists even in silence, and that the universe is calm, gentle, and profoundly eternal at every scale. The final slowness. The end of everything. The universe, after trillions upon trillions of years, reaches the threshold of a profound quiet. Stars have burned out, galaxies have drifted apart, black holes have evaporated, and photons have faded into near invisibility. Even the subtle quantum whispers that once lingered are now almost imperceptible. This is the stage of the final silence, the ultimate calm of a cosmos that has grown empty, cold and still, a place where time itself seems to stretch into infinity. At first, the silence is subtle. Motion continues at a slow, almost imperceptible pace. Particles drift in the vast expanse, barely influenced by distant gravity. Radiation is scarce, temperature hovers near absolute zero, and energy is spread so thin that even the smallest spark seems monumental. The universe is no longer vibrant, no longer bustling. It is patient, calm and enduring, a grand testament to the slow, inevitable flow of time. Imagine floating in this quiet cosmos. There is no light to guide you, no warmth to comfort you, no stars to mark distance. Everything is black, vast and empty. Even the smallest remnants of matter are isolated, each particle alone in the infinite void. Space itself seems to have become a silent ocean, stretching endlessly in all directions, carrying the echoes of all that has ever been. The final silence is not abrupt, not catastrophic. There is no crash, no bang, no sudden end. It is a gradual fading, a patient transition from the subtle motions of particles and radiation to near perfect stillness. Even entropy, the slow spreading of energy, has reached a state where change occurs so rarely it is almost imperceptible. The universe moves forward, but in a rhythm so slow, so delicate that it feels eternal. This silence is absolute in scale, yet gentle in nature. No explosions, no dramatic collapses, no cataclysmic endings occur here. The universe simply exists, a patient observer of its own fading history. It is the final chapter of cosmic time, where space, matter and energy remain, but motion, warmth and light have become faint echoes of what once was. Even as the universe approaches ultimate stillness, continuity persists. Particles drift. Quantum fluctuations continue at minuscule scales, and the laws of physics endure. Though stars, galaxies, and black holes are gone, the universe is not nothing. It is quiet, yes, and cold, yes, but ordered and calm, a final expression of elegance that stretches across the deepest reaches of time and space. Imagine the vast distances between particles now. They float alone, carrying the faintest traces of energy. No collisions occur, no fusion, no movement of celestial bodies. Just patient drifting slow beyond comprehension. Even the gentle ripples of quantum activity are rare and faint. The cosmos has become a frozen, almost eternal stage, where time is a vast, gentle flow and motion is almost imperceptible. The final silence teaches awe and humility. Everything from the smallest particle to the largest galaxy has participated in the grand unfolding of existence. Human life, stars and civilizations were brief flashes compared to this patient march of cosmic time. Yet even in near absolute stillness, the universe retains its beauty. It is calm, vast and serene, a silent witness to the deep story of creation, evolution, and ultimate fading. There is poetry in this ultimate quiet. Even as light vanishes and matter drifts alone, the universe exists in perfect stillness. There is no urgency, no chaos, no danger. There is only patient endurance, a rhythm of existence that continues quietly, steadily, and eternally. Even endings, when expressed on such a grand scale, can be calm, gentle, and infinitely beautiful. Close your eyes and imagine this far future. Space stretches endlessly in every direction. Particles drift alone, faintly moving in the near absolute void. There are no stars, no galaxies, no light, only silence. And yet, In this silence, the universe is perfect, complete and enduring. It is a meditation on time scale and the patient, gentle unfolding of all things. The final silence is not an end in the catastrophic sense. It is a transition, a calm conclusion to a universe that has aged beyond comprehension. It reminds us that even in endings, there is beauty, elegance, and serenity. The cosmos, having completed its journey from vibrant birth to patient stillness, rests in a calm eternal silence, a testament to the profound and gentle poetry of existence itself. Time stands still, eternity in the void. As the universe drifts into its final eons, a strange phenomenon emerges, the perception that time itself has slowed. Stars have burned out, galaxies have faded, and the last photons drift silently across the cosmos. Space is vast and nearly empty. Temperature hovers near absolute zero, and motion is minimal. In this calm, cold void, time feels suspended, stretched into near infinity, as though the universe has paused to catch its breath, leaving only quiet and stillness behind. Imagine drifting alone through the darkness, without stars to mark days, without galaxies to give perspective. Time loses its familiar rhythm. One moment blends into another. Billions of years feel like centuries, and centuries stretch like eons. The universe moves forward, but at a pace so slow, so delicate that it seems almost eternal. In this patient stillness, everything is quiet, almost meditative, a cosmic lullaby for the end of everything. Even at the smallest scales, motion continues. Particles drift alone in the vast void. Quantum fluctuations whisper softly, and the faintest traces of radiation linger, stretching across distances too immense to measure. Yet the pace of change is imperceptible. Atoms rarely interact. Photons are almost gone, and the once vibrant energy of stars has dissipated. The universe has become a silent, patient ocean of matter, energy, and space, existing in a state that feels beyond time itself. The stretching of space magnifies this stillness. Distances between the few remaining particles grow ever wider. Even gravitational effects weaken, and motion slows to near imperceptibility. Every process occurs at a tempo so languid that it challenges comprehension. The universe has become an endless expanse of calm, quiet and patient existence, a place where eternity is not just measured by years, but by the nearly infinite pause between events. Picture floating through this void. No light illuminates your path. No warmth penetrates your senses. Only darkness stretches endlessly in all directions. Particles drift alone, isolated in the near-infinite emptiness, moving almost imperceptibly. Even the laws of physics operate at a level so subtle it feels as if time itself has nearly stopped. And yet, there is order, there is rhythm, there is quiet elegance in the slow, gentle unfolding of this cosmic eternity. In this stage, the universe teaches a profound lesson. Time is not absolute. It is relational, shaped by motion, energy, and perception. When energy thins, when motion slows, when light and heat vanish, time feels suspended. The universe becomes a patient witness to its own fading, a place where beginnings and endings blur, and where every particle drifts alone, marking the slow passage of eons with quiet dignity. Even the faint quantum whispers continue in this near-eternal void. Particles appear and vanish, energy flickers in subtle bursts, and the vacuum hums softly. These echoes are the universe's quiet heartbeat, the last reminders that even when stars, galaxies, and photons have gone, existence persists in small, gentle motions. Time may feel frozen, but it continues, stretched into infinity, moving patiently through the quiet emptiness. Imagine standing or floating in this vast void, where the concept of now stretches into eternity. There is no calendar, no day or night, no movement to mark passage, only patient drifting, only silence, only the soft hum of quantum activity. And yet even in this deep stillness, there is a profound sense of beauty. The universe, though nearly devoid of light and matter, remains ordered, calm and elegant, a quiet monument to patience, scale, and duration. The calm of eternity also brings reflection. Human lives, planets, civilizations, even stars and galaxies are fleeting against this backdrop of suspended time. Yet this near-eternal stillness is not empty. It is filled with potential, with the quiet echo of past events, and with the subtle memory of the cosmos itself. Everything that once existed continues to ripple faintly across the void, a testament to the gentle persistence of existence. Close your eyes and imagine floating through this eternal void. The universe is vast, empty, and still. Time feels suspended. Particles drift alone, radiation is nearly gone, and even motion has slowed to imperceptibility. Yet, in this silence there is grace. In this stillness, there is poetry. In this near-eternal calm, the universe teaches patience, quiet, and the profound beauty of existence stretched across unimaginable eons. In the vast, patient void of cosmic eternity, time is no longer a force. It is a quiet companion. Every particle, every fluctuation, every remnant of energy moves with gentle, almost imperceptible rhythm, reminding us that even when everything fades, the universe endures. Time stands still, yet it flows, silently, endlessly, and profoundly, in the eternal calm of the cosmos. The last black hole, a lonely giant in the dark. In the distant future, when the universe, cold, dark, and nearly empty, one of the last remnants of cosmic history is a black hole, the final giant in a universe that has aged beyond imagination. Black holes, once common in galaxies and clusters, have largely evaporated through Hawking radiation, leaving only the few most massive survivors. These lonely giants drift through space, carrying the memory of countless stars, galaxies, and civilizations that once existed around them. Imagine a black hole, enormous and silent, floating in near absolute emptiness. Its gravity is immense, yet there is little left to consume. No stars approach, no gas clouds swirl into its depths. Its event horizon, the boundary beyond which nothing can escape, glows faintly with the last traces of Hawking radiation, a dim, patient reminder that even in solitude, the universe moves forward. The last black hole is both a monument and a witness. It contains the remnants of countless stars, the echoes of ancient supernovae, and the gravitational imprints of vanished galaxies. Though isolated, it remains connected to the universe's deep history, a solitary guardian of memory in an empty cosmos. It drifts silently through space, unaffected by the emptiness surrounding it, a calm giant floating in eternal darkness. Hawking radiation, though faint, continues to carry energy away from the black hole over unimaginable time. Slowly, imperceptibly, the black hole loses mass, shrinking ever so gently. It is a patient process, spanning billions upon trillions of years. No explosion marks its decay. There is no chaos. Instead, the giant fades with quiet dignity, its energy dispersing into the cold, empty universe, becoming part of the subtle background of the near-infinite void. Imagine drifting near the event horizon. Time bends, light stretches, and the universe behaves strangely in the black hole's presence. Yet even here, in the most extreme gravity, there is calm. The black hole does not rage or collapse violently. It is patient, eternal in its scale, a silent echo of the forces that shaped galaxies and stars long ago. It is the universe's quiet sentinel, a monument to the power and elegance of cosmic evolution. Even in isolation, the black hole shapes its surroundings, subtly bending space and influencing distant particles. Its gravitational pull extends across empty distances, drawing wandering matter and radiation into gentle arcs. Though the universe has grown cold and empty, this last black hole preserves structure, continuity, and a sense of order, a reminder that even in solitude, the cosmos is not entirely still. Over time, the black hole's mass decreases. Hawking radiation grows more significant as the black hole becomes smaller. Eventually, the last giant will release its remaining energy in a final gentle whisper, fading into the background of the universe. This process is slow and serene, unlike the violent deaths of stars or the explosive collisions of galaxies. It is the patient closure of one of the universe's grandest phenomena. Picture the last black hole drifting through a vast, empty expanse. No galaxies, no stars, no photons accompany it. Only faint quantum fluctuations, subtle remnants of past energy, and the calm fabric of space itself exist around it. And yet, this lonely giant remains majestic, a symbol of endurance, strength, and quiet beauty amidst the deep cosmic void. The final black hole teaches lessons in scale, patience, and impermanence. Even the most powerful, mysterious, and massive objects in the universe are not eternal. Everything eventually fades, even in the absence of external disruption. The slow evaporation of the last black hole is a gentle demonstration of cosmic humility, a quiet reminder that time, energy, and matter are finite, yet enduring in subtle ways. Close your eyes and imagine drifting alongside this final giant. Its event horizon glows faintly with the last traces of energy. Space stretches infinitely around it. Time seems almost suspended, yet the black hole moves patiently, steadily, silently through the calm, cold void. In this, there is poetry, the quiet endurance of a singular, massive entity in a universe that has aged into serene emptiness, a final monument to the passage of eons. Even as it vanishes, the last black hole does not shout or erupt. It fades calmly, leaving behind the quiet fabric of space, the faint hum of energy, and the enduring memory of its existence. It is a patient, solemn farewell, the final echo of gravity's grand symphony, and a reminder that even in darkness there is calm, order, and a profound, distinct beauty in the cosmos. The end of matter, from particles to nothingness. In the far, far future, after galaxies have drifted apart, stars have burned out, and even the last black holes have faded, the universe approaches a stage where matter itself begins to vanish. What once seemed permanent, the building blocks of everything, slowly decays, leaving behind an almost perfect emptiness. This is the end of matter, a quiet, patient process in which particles gradually succumb to the deep, unyielding laws of physics, drifting toward nothingness. At first, the decay is imperceptible. Protons, neutrons, and electrons, the particles that form atoms, stars, and planets, persist for unimaginable spans of time. Even the most massive objects retain their structure, bound by forces older than life itself. But eventually subtle quantum processes begin to erode matter at its most fundamental level. Protons may decay, atoms dissolve, and isolated particles drift alone in the vast void. The universe, already empty and cold, becomes even more silent, more patient, and more profound in its stillness. Imagine drifting through a region of space where only a few lonely particles remain. They move with minimal interaction, separated by incomprehensible distances. The universe has grown vast beyond measure, and the rare encounters of matter become even rarer. Collisions are almost non-existent, and energy is so diffuse that even the smallest spark of interaction seems monumental. Here, the cosmos teaches the gentle art of impermanence, showing how even the building blocks of reality are not eternal. Proton decay, a theoretical process predicted by some physicists, becomes the dominant agent of matter's disappearance. Over unimaginable trillions of years, protons, once stable, seemingly eternal, spontaneously transform into lighter particles, releasing faint energy into the empty cosmos. Atoms unravel, molecules dissolve, and all familiar structures vanish. The universe, once filled with stars, planets, and life, becomes a place where matter itself is a rare relic, whispering faintly of the eons that have passed. Even as matter disappears, there is no drama, no explosions, no catastrophic destruction. The process is gradual, patient, and almost meditative. Particles drift, decay, and transform silently, in accordance with the laws of physics. The universe becomes a calm, empty expanse, a stage for the subtle dissolution of everything that once existed. It is an elegant, poetic transition from existence to near-nothingness, from density to emptiness, from substance to the profound quiet of the void. Imagine floating through this emptiness, observing the last atoms dissolving into smaller particles. No stars illuminate the way, no galaxies provide context, only vast distances separate remnants of matter, and each particle drifts silently, carrying memory of a universe long gone. Even in this near-total decay, there is structure. Particles follow gentle trajectories, energy diffuses subtly, and the cosmic fabric persists, calm, orderly, and enduring. The end of matter also teaches humility. Human life, civilizations, planets, and even galaxies are fleeting compared to these processes. Matter, which seemed permanent and solid, is revealed to be temporary, subject to decay over unimaginable timescales. Yet this decay is not tragic, it is patient, gentle, and imbued with a strange elegance. The universe shows that endings can be calm, serene, and even poetic. Quantum fluctuations continue to ripple faintly, even in the absence of most matter. Particles appear and vanish, energy drifts, and space hums quietly with potential. These soft echoes are the final whispers of existence, a subtle reminder that the universe, though stripped of its matter, continues to move, to exist, and to endure. Even in near-total emptiness, there is rhythm, elegance, and continuity. Close your eyes and imagine the last atoms fading away. Vast distances stretch endlessly, particles drift alone. Energy is minimal, space is cold, silent, and infinite. Yet in this emptiness there is beauty. The universe continues patient and calm, a quiet monument to time, impermanence, and the enduring poetry of existence. The end of matter is not chaos. It is a gentle, inevitable transition into the profound stillness of the cosmos. Even as particles dissolve, as protons decay, and as all familiar structures vanish, the universe persists. Its sadness is complete yet calm. Its emptiness is total yet elegant. Matter may end, but the cosmos continues, patient, quiet, and eternal, a final testament to the gentle, enduring rhythms of creation, existence, and fading. The final energy, last motions of the universe. Even as matter fades and particles decay, energy persists. The universe may be cold, empty, and nearly devoid of structure, but subtle motions and faint traces of energy continue. This is the stage of the final energy, the last whispers of cosmic movement, where even the tiniest remnants of radiation, quantum fluctuations, and particle motion carry the final echoes of existence across the vast void. Imagine drifting in this near-empty universe. There are no stars, no galaxies, no warmth. Space stretches endlessly, cold and silent, yet everywhere around you, energy lingers in the smallest, faintest forms. Hawking radiation, residual photons and quantum fluctuations trace delicate arcs, subtle currents in a cosmos almost entirely still. Even in near total emptiness, the universe is not dead. It continues its patient, silent dance, moving according to rules older than time itself. This final energy is almost imperceptible. The motions are faint, stretching across distances that defy human comprehension. Particles drift alone, influenced only by the weak whispers of gravity and the subtle push of residual radiation. Even the vacuum itself hums with tiny fluctuations, a delicate song of persistence. Though imperceptible to human senses, this energy ensures that the universe continues, even as all familiar forms of matter and light have vanished. Imagine following the last remnants of motion. A single particle drifts, guided by the faint tug of gravity from a distant, evaporating black hole. Another particle jitters gently due to quantum fluctuations, a subtle dance in the empty void. Hawking radiation disperses the final energy of vanished black holes, tiny bursts of light and heat travelling across the dark cosmos. The universe has slowed to a nearly eternal calm, yet it is not completely motionless. The poetry of the final energy lies in its subtle persistence. Even as all matter disappears and light fades into the farthest reaches, energy remains. It travels, shifts and evolves quietly, carrying memory and structure across the void. It is the last heartbeat of a universe that has aged beyond imagination, a gentle reminder that even in emptiness the cosmos continues to exist, patient, silent and profound. Energy at this stage moves so slowly that time itself seems almost suspended. Collisions are rare, motion is minimal, and temperatures hover near absolute zero, yet even the smallest ripple matters, a reminder of the laws that govern all things. The universe has entered a state of near-perfect equilibrium, where motion is subtle, energy is faint, and space stretches endlessly, calm and eternal. Imagine observing the last photons, drifting slowly through the cold void. They move without haste, barely interacting, stretching infinitely as the universe expands. The last gravitational effects ripple faintly through empty space, shaping trajectories without notice. Even the most subtle quantum processes contribute to the quiet, ongoing motion. In this silence, the cosmos seems almost alive, moving patiently in a rhythm too slow to perceive, yet undeniably present. This stage is not dramatic. There is no explosion, no violent end, no catastrophic collapse. The universe does not scream or implode. It drifts quietly, elegantly, and serenely, a calm symphony of faint energy, ghostly particles, and subtle motions. It is a meditation on the nature of persistence, showing that even when all familiar forms vanish, the universe continues softly and without urgency. Close your eyes and imagine this far future cosmos. The last traces of energy drift across vast empty distances. Motion is almost imperceptible. Particles and photons move slowly. Quantum fluctuations hum faintly, and the fabric of space itself stretches in silence. The universe, though empty and cold, continues, patient, gentle, and eternal. In this quiet, you can sense the profound poetry of persistence, the subtle rhythm of final energy, and the calm, enduring beauty of cosmic time stretched to its limits. The final energy is the universe's ultimate whisper, the last evidence that motion and existence endure, even in a cosmos stripped to near nothingness. It is subtle, patient, and eternal, a quiet, graceful prelude to the ultimate stillness that awaits in the final part. The absolute void, the universe at its end, at last. The universe reaches its ultimate state, the absolute void. Matter has vanished, energy has faded into near invisibility, black holes have evaporated, and even the faintest photons have stretched into near nothingness. The cosmos has transformed into a vast, silent, timeless emptiness, where nothing moves, nothing shines, and nothing exists in any familiar sense. It is the end of everything, the final stillness, the ultimate calm. Imagine floating through this void. No stars illuminate the darkness, no galaxies mark distance, no radiation warms the emptiness. Only space itself remains, stretched endlessly, cold and absolute. Even the gentle hum of quantum fluctuations, once the soft whisper of existence, is so faint it is nearly gone. The universe has become a pure, infinite silence, an eternal black canvas of nothingness. Here, time itself seems meaningless. Without energy, motion, or matter to measure its passage, seconds, years, and eons lose all meaning. There is no change, no rhythm, no heartbeat. The cosmos is frozen, yet eternal. It exists without events, without progression, a calm the infinite expanse where even the concept of now becomes irrelevant. It is a quiet so deep that it surpasses comprehension, a stillness so absolute it feels like the universe itself is holding its breath. Even in this emptiness, the structure of the universe, the geometry of space itself, remains. The fabric of space-time stretches silently, a gentle, patient scaffold that persists even in the absence of everything else. Distances are infinite, directions meaningless, and yet the void is not chaotic. There is order, elegance, and a kind of serene symmetry in the absolute emptiness. Imagine drifting alone, utterly alone through this vast void. There are no particles, no energy, no light. Even the tiniest remnant of matter has disappeared. Space is endless and unbroken, a perfect canvas of nothingness. The universe has returned to a state closer to the void from which it was born, a calm, silent, and eternal absence. There is no motion, no sound, no warmth, only the profound stillness of existence stretched to infinity. This absolute void is not frightening. It is gentle, patient, and meditative. It teaches a final lesson about impermanence, scale, and cosmic perspective. Everything that ever existed, stars, galaxies, black holes, photons, even quantum fluctuations, has passed. And yet the universe continues in its own quiet, eternal way as an empty, serene expanse. There is poetry in this ultimate stillness, a calm grandeur that surpasses any human imagination. Even as the universe rests in this perfect emptiness, it carries the echoes of all it once was. Every star, every galaxy, every particle that drifted through space has left its mark on the fabric of space-time. These echoes are faint, imperceptible, yet they exist in principle, reminders of creation, evolution, and the patient passage of cosmic time. The absolute void is not simply nothing, it is the culmination of everything reduced to calm, silent essence. Close your eyes and imagine the absolute void. Space stretches endlessly, perfectly still and empty. Time has no meaning, matter has vanished. Energy has faded. The universe rests in eternal quiet. And in this final stillness there is beauty, the elegance of the cosmos stripped to its simplest, most serene form, the patient unfolding of time reaching its ultimate conclusion. The universe at its end is a meditation on eternity. It is calm, silent, and infinite. There is no violence, no chaos, no motion, only the profound, eternal stillness of the absolute void. In this final chapter, Everything concludes gently, patiently, and gracefully. It is the quiet poetry of existence at its absolute limit. A serene cosmic lullaby, a perfect ending to the long, patient journey of the universe.